Hello everyone, welcome to Infinity Physics. In this lecture, we will study Galileo's law. So, by observing the motion of objects on an inclined plane, Galileo deduced that objects move with a constant speed when no force acts on them, that is, in absence of frictional force. He also observed that when a marble rolls down an inclined plane, its velocity increases under the effect of gravitational force and it will attain a constant velocity by the time. Now, suppose the marble is allowed to climb up an inclined plane, then what will happen? Its velocity decreases, that is called the retardation. And if it is allowed to move on a horizontal surface where there is no friction, then it will move with the constant velocity. You can see in the picture, right? So the marble will move with the uniform velocity when it is allowed to roll on a horizontal frictionless surface. Now, Galileo argued that when the marble is released from left, it would roll down the slope and go up to the opposite side of the same height from which it was released if the inclination of the planes on the both sides are equal. Then the marble will climb up the same distance that it was covered while rolling down. Now, if the angle of inclination of the right side plane were gradually decreased, then the marble would travel further distance, it will reach the original height. If the right side plane were ultimately made to 0, that is the angle is 0, it would made horizontal, then the marble would continue to travel forever trying to reach the same height that it was released from. The unbalanced forces on the marble in this case are 0. It thus suggests that an unbalanced force is required to change the motion of the marble, but no net force is required to sustain the uniform motion. But if there is a friction, there is an unbalanced force, then the marble will ultimately comes to rest. Now let us try to study the Galileo's laws in more detail. So here you see there are two inclined planes, right? And if I allow to roll the ball on this inclined plane, then initially due to the gravitational force, the speed, the velocity of this ball increases, right? Because the gravitational force pulls this ball down. Now when it reaches here, it will acquire some velocity. Right, now let us assume that the ball has acquired velocity of 20 meter per second. Now on this plane, now horizontal plane, there is no friction, right? Hence its velocity will not decrease and there is no other force to increase the velocity. Then the ball will continue to move with the same velocity 20 km per hour. Now when it climbs up, its velocity decreases, right, and it will reach the same height. That is, if this height is 5 feet, then it will again cover the same height, that is the 5 feet, and then it will stop. Now suppose if I made this angle, right, with the base small, then what will happen? Again the ball starts rolling from this position. It again acquires the same velocity, and then when it climbs up, its velocity decreases, and when it reaches the same height, right, if this height is 5 feet, then again it will stop at the 5 feet. Now in this case, the object has traveled the larger distance to acquire the same height. You can see that this distance is larger compared to this distance. Now similarly, again if I decrease this angle, right, again if I decrease this angle to very let's suppose 20 degree or 10 degree, right, very less, near to 0, then what will happen? Again the ball will start its velocity increases when it's coming down the slope, and it attain a constant velocity, and then it will stop when it acquire the same height. Now suppose if I made this plane completely horizontal, right, means the angle is 0. So here you can see that this plane, the inclination is completely 0. So in that case, what will happen? The ball will continue to travel, right? Suppose here it starts its velocity. So initially 0. Now it is moving down, then it will acquire a constant velocity. Here you can see that there is no slope at this particular position. So it will acquire a constant velocity. Let us assume that it acquires velocity of 20 km per hour or 20 meter per second. Then what will happen? The ball will continue to move with the same velocity because there is no friction. We have assumed that there is no friction. Then what will happen? The ball will continue to move with the same velocity until it acquires the same height from which it was released. So here you can see that from this position, right, from this position till it acquires the same height, it will move with the same velocity, right, that is 20 meter per second. We assume that it is moving with 20 meter per second. In this case, we are not giving any external force, right? In this case, when it here, from this position to the end, we are not providing any external force. There is no friction force which reduces its velocity, and there is no other external force which increases its velocity. Hence, the object is moving with the uniform velocity, constant velocity. So in this case, we can conclude that the object will move with the uniform motion when there is no external force is acting on it. Also, we can say that we doesn't need any external force to keep the body in uniform motion. So here you can see that Galileo postulated that if the friction could be entirely eliminated, means removed, and if the opposite inclined ramp, that is a plane, were elevated at nearly 0 degree angle, then the ball would roll almost forever an effort to reach the original height. And if the opposing incline was not even inclined at all, means if two planes are completely, if a plane is completely horizontal and suppose you are applying some force to move the ball, then the ball will continue its motion. If there is no friction, it will not stop. Means to keep a body in uniform motion, you don't need any external force. Thus, if unbalanced force do not act on the body will remain at rest or will move with the uniform velocity. So what are the conclusions? The body is at rest and no unbalanced force acts on it, it remains at rest. If the body is moving and no unbalanced force acts on it, it will continue to move with a constant speed. Now if the unbalanced force acts on the body, right, then the body will accelerate, that is its velocity increases. The idea was suggested by the Galileo was later formulated into laws by the Newton. So here you can see that Newton's formulated the law of inertia on the basis of the idea given by the Galileo, that we'll study in the next lecture.